One more thing about the existence of limits is going to be this example, and you'll notice in this graph we've got a straight line, but at this spot right here is a hole, and then the point for that x value is placed somewhere else. This is a removable discontinuity, and we want to know what happens when we do that. So we think about these different limits. Notice over here I've got limits all surrounding this value at x equals 2. So this is the x value in question here for every step of the process. But this one has x approaches 2 minus. That means from the left. So as I'm coming in from the left, the y value that this one gets really close to looks to be 1, 2, 3, 4, 5, 6. So it's at 6. This one is going to be equal to 6. So if we can get a value for it, then we can say, yes, it does exist. So that one does exist. That's a yes. As we're coming from the right, same thing happens. We also have a 6, and this is a yes. It doesn't matter that that point is hollow. It's as we get really, really close to there, are we approaching a certain value? And the answer in both of them is yes. Now, if the pair of one-sided limits is the same, then what our theorem just told us was that this one is also going to be the same, that this two-sided limit exists and it's going to be the same as each of those. And so that one also exists. The question that a lot of people have is, this point, does that throw us off? The answer is really no, that doesn't actually throw us off in this case because it is just a single point. As you get closer and closer to here, if you only exclude this point, everything else points towards the limit being 6. So if that's the case, then it does exist. That point of discontinuity really doesn't change anything for us in this example.